Hey everyone, welcome back for another deep dive. You guys sent in some really cool research on VisionZip.
VisionZip. Yeah,
Yeah.
it's a really clever way to make those big vision language models, those VLMs,
Right, the VLMs?
way more efficient.
Yeah, so VLMs, those are the AI models that can understand like pictures and text, right?
Exactly. Like imagine, you show it an X-ray
Mm-hmm.
and you're like, hey, is there a fracture here? Or like you show it a picture of I don't know, a busy street scene
Right.
and you ask it to describe everything that's going on. That's the kind of power we're talking about with these VLMs.
So they're like the ultimate multitaskers, or right, like they can do it all.
Yeah.
But I mean, if they need so much data to work,
Yeah.
doesn't that like limit how we can actually use them, for everyday stuff?
That's exactly the problem that VisionZip is trying to solve. You see, the thing is,
Okay.
current VLMs use way more data than they actually need, like way more visual tokens.
Okay, hold on. Back up. What are these tokens now?
Think of it like this. You know how computers use code to represent information?
Yeah.
Tokens are kind of like bits of code
Okay.
that represent parts of an image.
Gotcha. Okay.
So each token tells the model something about what it's seeing, right?
Okay.
But the research on VisionZip, and actually they have a really cool visualization in figure 2 of the paper.
Oh, nice. I like visuals.
It shows that a lot of these tokens, they barely get any attention from the model.
Really?
Yeah, it's like
Because they're just kind of like taking up space.
they're just kind of there. Yeah.
Wow. Okay, so then what's VisionZip doing about it?
Okay, so VisionZip, it's like a zip file. It compresses all that visual data
Oh, I get it.
without losing the important stuff.
Okay.
And it does it in 2 steps.
Okay.
The first step is it picks out the most important visual tokens.
Uh-huh.
And it does this based on what are called attention scores.
Mm-hmm.
So basically, how much the model is focusing on each token.
Oh, so like the higher the attention score,
Yeah.
the more important that token is.
Exactly.
Exactly. Makes sense. And then what's step 2?
So step 2, it takes all the other tokens, the ones that weren't super important,
Okay.
and it kind of merges them together
Okay.
based on how similar they are. It's kind of like, if you had a really long text,
Right.
and you were like, okay, I can combine these 2 sentences because they're saying basically the same thing.
Right. So you're like summarizing it.
Exactly. Exactly.
Okay. Interesting. So it's making it more efficient.
Yes.
But is it like, I mean, does it actually work? Like, can it still understand the images as well?
That's the surprising part. VisionZip, it manages to keep, over 90% of the accuracy of the original model,
Oh, wow.
even though it's using way fewer tokens.
So it's like getting the same quality,
Yeah,
but like way faster.
much faster. Yep.
Okay, so how much faster are we talking here? Like, give me some numbers.
The research actually shows it can reduce what's called the pre-filling time. So like the time it takes for the model to start generating a response
Uh-huh.
by up to 8 times.
Wow, 8 times, 8 times.
That's amazing. Okay, so how does it do that? Like what's the secret sauce behind VisionZip?
It all comes down to this thing called, I mentioned it earlier, attention sync. So what happens is the visual encoders, right, the part of the VLM that's translating the image into tokens,
Okay.
they tend to put most of the information into just a few key tokens.
Oh, okay.
And then the rest of them are kind of like, meh, not really contributing that much.
Gotcha. So it's like almost like they're overloading those few tokens
Yeah, exactly.
with all the info, and then
Exactly.
the rest are just kind of like sitting there empty.
Yeah, it's like trying to fit, a whole gallon of juice through a tiny straw.
Right,
You're
exactly.
going to create a bottleneck.
Yeah.
And so VisionZip basically takes advantage of that. It's like, okay, I know that most of the information is concentrated in these few tokens.
Mm-hmm.
So let's just focus on those and ignore all the noise.
I see. Smart.
Okay, so that makes sense. But, I'm thinking fewer tokens. Wouldn't that mean like
Yeah.
maybe it's missing some details in the image?
It's a good question.
Hmm.
But the research actually shows that VisionZip does a really good job of, preserving the accuracy.
Mm.
Because those dominant tokens,
Yeah.
they're packed with so much information.
Yeah.
And then the merging process makes sure that, the important details aren't lost.
Okay, so it's like it's choosing its words carefully,
Exactly.
even though it has fewer words to work with.
Exactly.
Gotcha. Okay. So, I mean, this is all really promising, this VisionZip. It's not just a quick fix. It's like a whole new way of thinking about how these VLMs should work.
I think that's a great way to put it. It really does.
Yeah, it's exciting stuff. I'm curious, though.
Yeah?
How does VisionZip stack up against some of the other methods out there that try to, reduce that token count?
That's a great question. And that's actually what we're going to talk about next. We'll dive into how VisionZip compares to those other techniques.
All right. Sounds good. I'm ready.
So you're probably wondering, like, okay, how does VisionZip
Yeah.
actually compare to these other methods for, cutting down on tokens?
Exactly. Yeah. Like, what makes it so special? You said there are these other techniques out there.
Right. So there are other techniques like fast VLM,
Okay.
sparse VLM,
Yeah.
and they kind of do things differently. What they do is they rely a lot on the text input
Okay.
to decide which visual tokens are important.
So they're like looking at the words you're giving it with the image.
Exactly. They're kind of like analyzing how those words
Okay.
and the image tokens are interacting inside the model.
Gotcha.
And then they try to prune away the tokens that they think are, least relevant.
So it's kind of like they're listening to the conversation between the text and the image.
Yeah, that's a good way to put it.
And then they're like, okay, this visual detail not really adding much to the discussion.
Exactly.
Okay, so what's wrong with that?
The problem is
Yeah.
it assumes that.
Yeah.
The visual encoder, the part that's, turning the image into those tokens in the first place.
Right.
It assumes it's already done a good job
Uh-huh.
of like spreading information evenly across all those tokens.
And we know that's not always the case, right?
Right. Cause of that attention sink we talked about.
Yeah.
Remember, it tends to cram everything
Yeah.
into a few tokens.
Overload them.
Exactly.
Leave the rest empty.
And so these text-reliant methods, they can actually end up making some bad choices.
Oh, how so?
They might pick tokens that are representing, like, the background of the image
Uh-huh.
or some tiny little detail in the corner.
Right.
But they miss, like, the real important stuff.
Oh, that's hidden in those, like,
That's hidden in those dominant tokens.
those dominant tokens. Okay.
Exactly.
So they're kind of getting, like, tricked by the visual encoder's bad habits.
Exactly. They're getting tricked
Mm-hmm.
because they're not really understanding how the visual encoder is actually thinking.
Right.
And that's where VisionZip comes in. VisionZip, it takes this what's called a text agnostic approach.
Okay, so it doesn't even care about the text.
It doesn't care about the text at all. It goes straight to the source.
Oh, okay.
It looks at how the visual encoder itself is processing information.
So it's like it's learned to speak the visual encoder's language.
Yeah, it's
It's like, I know your little secret.
It's like, I know how you think.
I know how you like to hide information.
I know where the good stuff is.
I'm going to cut through all that noise. Okay, I like that.
Yeah.
So that makes sense why it works better. But like, when does that really become important? Like, when do we really see the difference?
That's a great question. So think about a situation where you're having like a multi-turn conversation with a VLM.
Okay. Yeah.
So let's say you're discussing a picture of like a busy city street,
Okay, I can picture it. Yeah.
right? So in that kind of conversation, the topic is going to be shifting constantly. You might start by asking about, the types of cars in the photo.
Yeah. And then you might move on to like the architectural styles of the buildings.
Okay, right.
And those text-reliant methods, they'd be constantly trying to play catch-up.
Right, because they'd have to like rescan the whole image every time you ask a new question.
Exactly.
Based on those new words. Okay.
They have to reevaluate, okay, which visual tokens are important now based on this new question.
Got it.
VisionZip doesn't have to do that.
Because it's already done that work up front.
Okay.
It already knows.
So it's like it gives the VLM a long-term memory.
Exactly. Like, I already know which tokens are important,
Got it.
no matter what you ask me later.
So it's not just faster, it's like smarter. It's thinking ahead.
It's thinking ahead, exactly.
Okay, so what kind of real-world applications could really benefit from this? Like, where does this efficiency really matter?
Oh, there's so many. Think about things like, self-driving cars,
Yeah, okay.
medical diagnosis systems.
Where you need that real-time analysis.
Exactly.
Yeah.
VisionZip could make those systems so much faster.
Right.
Potentially, like, saving lives, preventing accidents.
Wow.
It's pretty amazing.
Yeah, so it's not just like a cool tech thing. It's like actually
Yeah.
has the potential to really make a difference.
Could have a real impact, exactly.
Good, that's awesome. And remember earlier you mentioned something about it being compatible with quantization.
Oh, yeah. Yeah.
Can you remind me how that works again?
Yeah, so quantization, think of it like, when you save a photo
Uh-huh.
and you can choose like a smaller file format.
Okay, yeah.
Right, you might lose a little bit of detail,
Yeah.
but the overall image is still, recognizable.
Okay.
Quantization does the same thing for AI models.
Oh, okay.
It reduces the precision of like the numbers that are being used in the model,
Gotcha.
which shrinks the size of the model.
Okay, so it's like downsizing your digital suitcase.
That's a great way to put it.
You're still bringing the essentials,
Yeah.
but you're like packing them more efficiently.
Exactly.
Yeah.
And here's the cool part. VisionZip and quantization, they work really well together.
Oh, how so?
So VisionZip reduces the number of tokens in the first place,
Right.
and then quantization comes in
Mm-hmm.
and compresses that data even further.
Ah, okay.
So it's like a 1-2 punch of efficiency.
I love that. Okay, so not only is it making the models faster, smarter,
Yeah.
it's making them lighter, more portable.
Exactly.
So we could be seeing these VLMs running on our phones.
Our phones, yeah. Smart home devices,
Smart home devices.
wearables even.
Wow.
The possibilities are huge.
That's crazy. Okay, so I'm thinking now, if we can strip away all these extra tokens, does that mean
Yeah.
maybe we're building these models wrong in the first place?
You've hit on a really interesting point. And actually, the researchers who created VisionZip, they even talk about this in their paper. It's like the fact that we can get rid of so many visual tokens
Yeah.
and still have the model work so well.
Yeah.
Maybe it means that we're overthinking things a little bit
Yeah.
when it comes to visual encoding.
So are we approaching visual information like the wrong way?
That's the big question.
Ooh, that's a good one.
And that's actually what we're going to talk about in the last part of our deep dive.
All right, I can't wait. Okay, so we're back, and we're tackling that big question. Are we approaching visual information the wrong way?
It really makes you think. VisionZip works so well, and it cuts out so many tokens,
Right.
but it still keeps the accuracy. So it does kind of make you wonder if, maybe we're doing something wrong.
Yeah, are we I don't know, are we overwhelming these models with way too much visual data? Like, they don't need to see all of that to understand, right?
That's what it seems like. Maybe these current visual encoders, they're just too focused on making all these tokens
Yeah.
without really thinking about if the tokens are actually useful.
So it's not just about how many tokens you have. It's like, are they good tokens?
Yeah, exactly. It's like, remember we talked about that attention sink?
Right, yeah. Where they cram everything into a few.
Exactly. So they cram everything into a few tokens,
Yeah.
and then the rest are just, kind of empty.
It's like a traffic jam of information.
Yeah. It's like a bottleneck.
Yeah, it is.
And so maybe that's actually, stopping the VLM from really understanding the whole picture.
Mm-hmm.
What if instead of cramming it all in, we spread the information out more evenly?
So you're saying instead of giving it this big jumbled pile of puzzle pieces,
Yeah.
you give it a more organized set.
Exactly. Make it easier to see the whole picture.
Okay. I like that. So VisionZip is kind of it's almost showing us a better way to do things.
Yeah.
Huh.
I think that's a really good way to put it. It's not just a fix. It's like a sign. Like, hey, maybe we need to rethink this whole thing.
Yeah, it's a wake-up call. We've been building these crazy Rube Goldberg machines
Yeah.
when there's probably a much simpler solution out there.
Exactly. And that's why I think this research is so exciting,
Yeah.
because it's really pushing the field forward.
Yeah.
It's telling us, hey, we need to come up with new ways to represent this visual information.
So what would those new ways look like? What are people thinking about?
Well, one idea is to create encoders that are more, I guess you could say, aware of the meaning of the image, like what's actually happening in the image.
Okay, so instead of just seeing a bunch of pixels, it actually understands what's going on.
Yeah, like it can say, okay, this is a cat chasing a mouse, or this is a dog playing fetch. Like it can understand the difference.
Right. So it's we're going from teaching them to see to teaching them to actually perceive.
Exactly, yeah. To
Yeah.
understand.
Wow.
And VisionZip is really helping to guide that research.
So it's this one idea has just
Yeah.
sparked all this new innovation.
It's amazing. It's really cool to see.
It really is. Okay, so let's recap here. What are the key takeaways from our VisionZip journey?
Okay, so we started by talking about how VisionZip makes these big VLMs way more efficient.
Right, by getting rid of all those unnecessary tokens.
Exactly. And we saw how it does that in 2 steps. First, by picking out the most important tokens.
Right, the VIP token.
Exactly.
Yeah.
And then by merging the rest based on how similar they are.
We talked about how VisionZip doesn't even need the text to figure out what's important.
Yeah, it just gets it. And we saw how that makes it work so much better than those other methods.
And of course, we can't forget about those amazing results.
Yeah, up to 8 times faster.
8 times faster.
It's pretty mind-blowing.
It's crazy. And it still keeps that same accuracy.
And we talked about how it works great with quantization.
Right, so we can shrink these models down even further.
Exactly, make them super portable.
But I think the biggest takeaway for me is that VisionZip is making us rethink how we approach these VLMs in the first place.
It's showing us there's a whole new world out there.
A better way to do
A
things.
better way to do things.
Sure.
Yeah.
This has been such a fascinating deep dive. Thank you so much for walking us through all of this.
It's been my pleasure. Really enjoyed it.
And to everyone listening, thank you for joining us. Keep those brains buzzing. We'll see you next time for another deep dive.